I want all of you to just go through the basics of MATLAB. So you just download the MATLAB basics. It's available 1 hour video and all on MATLAB. If you don't have a software, when you come to college, we will provide you, or it is available online to download. If you know, you can download it, we can give it to you later stages as well. So what it is required first, it is like what is a MATLAB, what are the coding process. You can all learn without the software itself, basics things. We will be, you need to try doing a control system, a very basic mini project which we are practicing from many, uh, means you're from your seniors as well. They are doing it. They have done quite a lot of mini projects using MATLAB. So you also should practice. We'll be studying so many techniques further, like Bode plot, Nyquist plot. All these things can be done using MATLAB. So you have to try. There are comments there are you can use the comments and you can do that. So you have to think slightly out of the box as well, and try using all these things and learn what is a MATLAB, because I know that you have not learned MATLAB. So if you find time of at least, you will get another 1 month before 1.5 month before second IA. So now it's just first IA is over. You are all almost free. No much of things involved with you. So what you can do is you can just go through the videos of MATLAB and learn that tool, how to use it, what are the basic commands to do that, all those things. So I want most of you to go through MATLAB. Maybe another 1 or 2 weeks or 3 weeks later, you will be having root lockers, Bode plot, Nyquist plot, and so many things. So this can be practiced in MATLAB. So you should do that. That time you will be able to get the software as well, and you can do. So now it is your time for you to learn the MATLAB. So 1 month you take to learn the MATLAB, and doing the program is just 1 hour or 2 hours. You can complete it off. So if you know the concepts, so understand the concept and learn. This is required for doing some small mini project on your control system. Okay, so that is what I want you to do, and I want you to practice more number of problems. If you are coming out with a new problem, I told you post it in the group rather than me. I have not seen anyone else posting any problems in the group. If you see MATLAB videos, put the link. I want to see some links in the uh, which is from the YouTube. You put the link so that others can also learn this kind of concepts. Okay, not only MATLAB, anything you can put it with respect to a control system in that group. Any applications you see, you can put it, or anything of that. Some 2 3 applications I have put in the group. You should see all these things. Okay, so we have also seen that, like, control system basically deals in many of the industrial applications as well as in aeroplanes and all. I have told you. So we were discussing this many days how the system can be reduced, if it is a complicated system, how it can be brought down, what are the mathematical equations with respect to that. All those things we have seen, what is an analogy system, how the block diagram reduction process, and then how the signal flow graphs can be done. We are now in the process of understanding the time response. You know that there are two types. It's called as first order system as well as second order system. We have completed the first order system, and we have started moving on to the second order system. So a few things I just want to just say you that uh, that second order system we are in, and we have understood the formal representation of second order system. The very important thing which you should understand, which I am going to use it in the further classes, will be the characteristic equation. So we have written the damping ratio. We know that there are four major concerns, like underdamped, undamped, underdamped, undamped is zeta is equal to 0, less than 0 is underdamped, critically damped is zeta is equal to 1, and overdamped is zeta greater than 1. So zeta is also the exponential decay frequency divided by natural frequency. So we have seen all these things, and then we have taken the Laplace transform for the equation, and C of S by R of S is equal to B divided by S square plus AS plus B, and the characteristic equation is S square plus AS plus B is equal to 0. So all these things we studied in the previous class. So this characteristic equation is very important for you to understand. And then we move on. We had been just moving on further. We have also seen B is equal to omega n square and A is equal to 0. Then the complex poles of the transfer function lie in the S plane. So this is all we studied in the previous class. So I think we have to start from the equation zeta, correct? See, till here we have taken, no, in the previous class, exponential decay frequency.
Yes, sir.
Yes, sir. Okay, so we'll continue from that further. So, as you know that zeta is called as the, you are able to see, no, the content.
Yes, sir.
Okay, so we will start from here. So we have been defining zeta. So zeta can be written as sigma divided by omega n, and when you substitute for sigma, that is minus a by 2, and it is modulus of that, so it will be a by 2 omega n. And if you write the equation for A, it will be in terms of zeta, it will be A is equal to 2 zeta omega n. So all of you can just write down that. So that is very basic equation for zeta. So all of you have completed that. Then we have found out A as well as B. So B is, you can see that B is omega n square. So this is B, and this is what A is in zeta. A is 2 zeta omega n. So when you use these two equations, we have studied in the previous class that C of S by R of S is equal to B divided by S square plus AS plus B. So you need to substitute all these things further, and you need to simplify it. So let us see what you're going to get. So we have B as well as we have A. So we are going to just substitute those things in equation 2. So substituting B, A and B. A is 2 zeta omega n and B is omega n square. So we got here omega n square and S square plus 2 zeta omega n s plus omega n square. So see this equation 2. Equation 2 you can see. So we have substituted here C of S by R of S is called as the transfer function for second order system, that is B divided by S square plus AS plus B. So you have to substitute A and B here. So let us see, when we substitute that A and B, A is 2 zeta omega n and B is omega n square. So all of you have substituted. So this equation is also very important. Put it in a box. We will be using it regularly, this equation. So the transfer function C of S by C of S by R of S is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. So it's very important equation, and it is the equation for transfer function. So I'll be using this equation again and again. So you need to remember this equation, and you should understand that we have taken from here that omega n square in this equation will come at least 4-5 times in next derivations. So you should not forget that from where it has come from. So I'll be saying that let us use the second order transfer function, means C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. Please put it in a square bracket, and that equation is important. So let us simplify it further. What I'm going to do here is I'm going to take s square plus 2 zeta omega ns. I am taking it outside in the denominator, so it will be left out with 1 plus omega n square divided by s square plus 2 zeta omega ns. So then we are going to simplify it further. So we will get in this way. I'm just rearranging the equation. So you can write the same equation in this form: omega n square divided by s square plus 2 zeta omega ns divided by 1 plus this term, omega n square divided by s square plus 2 zeta omega n s. So it is of the form C of s by R of s is of the form g of s divided by 1 plus g of s h of s. So you can see that it is g of s by 1 plus g of s h of s, and we have written here, you can see that what is g of s? G of s is omega n square, s square plus 2 zeta omega n s, and g of s h of s is given here. So h of s is what is h of s here? Any one of you? What is h of s here? If g of s is s omega n square divided by s square plus 2 zeta omega n s, what is h of s? You think and tell me. Have you written till there?
Yes, sir.
Yeah, so you can see, other than Sai, I am not getting any response from others nowadays. What you can just let me know what is h of s. What about others? What is h of s here? Anyone? Okay, fine. H of s, whether it can be 1?
Yes, sir.
Okay, that you should have told. So C of s by R of s is equal to G of s divided by 1 plus G of s H of s. So you can get G of s here as well as H of s will be 1. Okay. So we'll all of you have completed till here.
Yes, sir.
Okay, so what is this equation all about? G of s by 1 plus G of s H of s. Which one it is? Which it gives you an idea of? What is this? We have just written the exams also now. What is this? Gives an idea of g of s by 1 plus g of s h of s. Whether it is which feedback process?
Negative feedback.
Eliminating the feedback, sir.
Negative feedback. So
Yes.
negative feedback we have because we have already we have that g of s divided by 1 plus g of s h of s is negative feedback, We have studied all these things before as well and used the equation. So this second order system can be represented in the block form in this way. So this block is also very important. I'll be using these two equations, this equation and this block. I'll be using it again and again. So you need to know these things. So block representation for second order system is R of S is equal, R of S will come here, G of S is this one, H of S is equal to 1, and you are giving a negative feedback process here. So this is the block diagram for general second order system. So all of you draw that. So this block
Excuse,
diagram as well as the transfer function, you
excuse me,
should
sir.
remember. Yeah, tell me.
The block diagram is not visible, sir.
Block is there no here? Means you are not able to see?
Yes, sir.
Okay, one second. Now can you see?
Yes, sir. Now we can see.
No. So C of S by R of S, you got G of S divided by 1 plus G of S H of S. So that you can understand it is a negative feedback mechanism, and you have represented the second order system in a block form. So you have G of S is omega n square divided by S into S plus 2 zeta omega n, and H of S is equal to 1. So these are all representations of second order system. We have seen the transfer function for second order system. So transfer function is omega n square divided by 2 zeta omega ns plus omega n square. This equation will need it again and again. I am saying it for you. And this block diagram also we'll be using it further. So we'll be using these things in the module further. So you need to understand these things properly. All of you have completed till the block diagram representation of second order system.
Yes, sir.
Okay, then you can just write down the next topic, that is step response for second order system. Step response of second order system. We have studied the step response of first order system before, and we wrote all the time constants and all those things, and we have completed that in the previous class. Just I will you remember those things. We have studied this portion. This is what we studied, step response of first order system, where we have discussed about all this time constant, rise time and settling time and all those things. So here we are going to see the step response of second order system. So what I want to say you is read the question carefully and understand whether it is step response of first order system or second order system, what they are really asking you to write. Okay, so you should understand the terms properly when you study. So this module, you have to understand all these things, and then you can just write it out. It's not difficult at all. So here the questions, they may ask you explain the step response of first order system, explain the step response of second order system, or they may ask you questions like explain this. These things are there, no, step ramp and all. So they will ask explain the standard test signals. So this you may have to tell. If this topic is coming, means they will ask you explain time constant, rise time and settling time, they may ask you, or they directly ask explain the unit step response of first order system. These are some of the questions possible here. We have done one problem as well in the previous class. Then representation, this is the what we have studied is formal representation of second order system, how the second order system can be represented. So you if you have to understand what is characteristic equation and all. So this is just the representation of that, as well as we have seen how the representation of a second order system is with respect to transfer function. So that as well as in the block representation. So all these things, after understanding that, next topic comes for you is step response of second order system. So you are going to use the same block which you studied in the representation of second order system and continue further. Here you are going to see underdamped, undamped, all those kind of cases when zeta is less than 0, zeta is equal to 0, greater than 0, all those conditions we are going to see here. So, so all of you can just note down this step response of second order system. The step response of the system, you can see the block representation here, where g of s is omega n square divided by s into s plus 2 zeta omega n, and h of s is equal to 1. So now we will see underdamped case and then continue further. So all of you draw this diagram. Write down step response of second order system. This topic is very important, step response of second order system. So they may ask you explain underdamped case for the second order system with step response, or they may directly ask you to explain the step response of a second order system. So this underdamped case, we have a little bit of derivations to be solved, and we will be, this underdamped case is the case when zeta value is between 0 and 1. So 0 less than or equal to less than zeta less than 1. So we will, as I have told you, we are going to use these equations, whatever we studied before. So the poles of, so you can just note down this diagram. I will just wait for a minute and then we'll continue. So if you understand these things, it becomes very easy for you. We will be using some Laplace equations in this derivation. So make sure that you learn those equations. One of you can just post it in the group, the very basic Laplace equations and inverse Laplace equations. So we will start with it. All of you have drawn that figure. Have you drawn that figure?
Yes, sir.
Okay.
Yes,
So
sir.
yeah. So we'll start with underdamped case. So underdamped case is 0 less than zeta less than 1. So let us see. The poles of C of S by R of S is called as a transfer function. So poles of closed loop poles are complex conjugate and lie in the left half of S plane. This we studied in this previous class. So C of S by R of S is called as a transfer function. So what we have just completed is C of S by R of S is equal to C of S by R of S can be written as omega n square divided by this term, or it can also be written as G of S by 1 plus G of S H of S. So I have just used that here. C of S by R of S is equal to G of S by 1 plus G of S H of S, or the same equation what I just explained you now. So you all have studied the step function. So here it is already clearly mentioned that you're going to see the step response. So when you're having the step response mentioned there, you know that what is the equation for step response, that is R of t is equal to U of t. This we have studied here. Step response, R of t is equal to U of t. So we are going to use that R of t is equal to U of t, and when you take Laplace for that you'll get R of S is equal to 1 by S. This also you know. So I have just rearranged the equation C of S is equal to the same term, this term multiplied by R of S. So I have written it here. So till here there is no confusion or there is no new concept being introduced here. It is all the same. C of S can be written as omega n square divided by s square plus 2 zeta omega n s plus omega n square into R of S. R of S is known to be 1 by S. So we will try to substitute and then simplify it further. So all of you complete it till here. So write down and mark this underdamped case to be very important. Most of the question papers, they just ask the underdamped case specifically, and some of the cases they ask some 2 to 3 cases together. So this is little derivation is there for you to understand this underdamped case. So you'll get C of S is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square into R of S. All of you have completed that?
Yes, sir.
Sir.
Okay. So we will just substitute R of S and proceed further. So what is R of S? R of S was 1 by S. So you will get C of S is equal to omega n square divided by S into this term. So this equation can be rewritten in this form. So you can rewrite the same equation in this form: 1 by S minus this. You need to understand that this equation and this equation is the same. Just for the simplification, we have rearranged the equation in this form, that is 1 by S minus S plus 2 zeta omega n divided by S square plus 2 zeta omega ns plus omega n square. So if you try to get this equation out, you can find that these both equations are same. So it is just a representation of this equation in a different way. So what you can see is 1 by S minus. So if you can solve it in this form, fine, or you can just remember this part of it. So it's very important for you to simplify it further, that this equation omega n square divided by s into s square plus 2 zeta omega n s plus omega n square can be rewritten in this form: 1 by s minus this term. So when you just take the common denominator and do it, you will get the same answer. Means both the equations are same. So further, this term, this we are retaining it as 1 by s itself. This is the portion we are going to just modify it little bit and simplify it. So what we are going to do here is just you should understand, we are going to add omega zeta square omega n square and subtract zeta square omega n square. So when I add something and subtract, it's not going to create any difference for me. So here you can see that in the denominator I have added zeta square omega n square and subtracted zeta square omega n square. So this all you should understand and remember when you derive it. And 2 zeta omega n in the numerator I have split as zeta omega n plus zeta omega n. Now next step what I have done is s plus zeta omega n, I took it together, and rest of the terms I left it there. Here in the denominator also s plus zeta omega n square, I took it together, this term, and then this completely will give me s plus zeta omega n square, and this one I have taken omega n square outside and I wrote 1 minus zeta. So so I can just write this thing s plus zeta omega n square. So from this, which one you have taken here, this term, this term and this term you have taken and you wrote this way. So you'll get omega n square taken outside 1 minus zeta square. So this term I have used here to write 1s plus zeta omega n square. So this is what you know better. These things you have done plenty of times. So it's not a new for you to rewrite in this form. You know s square plus 2 zeta omega n s plus omega zeta square omega n square can be written as s plus zeta omega n whole square. So that you got it. Once you get this further, what we can do is, so omega n square into 1 minus zeta square, this term omega n square minus into 1 minus zeta square, I have replaced it as omega d square. So you should understand what are the changes we are doing it to derive it. So I have replaced this term as omega d square, or I can write omega d is equal to this one and the same. So frequency of damping oscillation, damped oscillation. So omega d is called as the damped oscillation frequency, and it is written as omega n square, omega d square is equal to omega n square into 1 minus zeta square. So till here you write it first, then we will continue further. If you understand this, it is very simple. So don't get into the complications of that. It is not that complicated. Only you need to understand what you have done, added, subtracted, taken terms together, and omega d square is omega n square into 1 minus zeta square, and so on. So next step also you can see I have just split the terms from here. This step you can see that I have just split the terms, s plus zeta omega n divided by the denominator minus zeta omega n divided by the denominator. So we have split the terms. So till here you write it. Once you complete, you just let me know. Then we'll continue further. If you have any doubts, you can discuss with me now. Is it clear for you?
Yes, sir.
Okay. Okay, thank you. So you can just complete it and let me know that once you complete it, so we'll continue further. See, it is nothing much here, only the rearrangement of terms to simplify it further. That's very important. That other than that, we are not doing anything too much. So some terms to add and some terms to combine, that you should know. So you can do it till here. I think it's time for us today. So all of you can complete till here, and we will continue from there on in the next class by taking the equation of C of S, and we'll further we have to simplify it and go ahead with that. So we'll see that. So you have completed till there?
Yes, sir.
Okay then. So we'll stop it for that. It's a longer derivation to do with. You need to just understand the Laplace transform and all those things. So better you just write down the equations, whatever you know, and just put it in the group. At least one of you can take it from the internet and put it there. Okay. So we'll stop it for today, and we'll continue in the next class from there onwards. So thank you all. Thank you. Thanks to everyone. So you can attend the next class. Thank you.
Thank you, sir.
Thanks.
Thank you, sir.
Yeah,
Thank
thanks.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.